Alrighty, so for example 3, we're using case 1 where we have product of distinct linear functions. We have 3 linear functions, right? So essentially we're going to be using this one right here, where we'll have each linear function as the denominator and then an a, b, and c on the top since we have 3 of them, okay? So that's where this is coming from. We have a, b, and c. And then again, remember, we're essentially doing this where we're working backwards. We started with this and we want to get to this phase number 1 and have the values for a, b, and c, which means we need to do this part where we make all the denominators the same. So this a is missing x plus 2, sorry, not x, is missing y plus 2 and y minus 3. So that's why I have that here, okay? And then plus b, this b is missing y minus 3 and a y, so that's why this is here. And then this c is missing y plus 2 and the y, so that's why this is here, okay? So now we're going to use this entire equation to find our a, b, and c. Remember, you can plug in values on the inside of these parentheses to get zeros, and so things will cancel out. They're both being multiplied by just a single y here, which means if we let y be 0, our b and our c would go away and we can solve for a. So we'll plug in 0 for y. When we plug in 0, we'll get negative 12. And then when we plug in 0 up here, we'll get negative 6. So a is 2. Okay, and now this one has a y plus 2, and this one has a y plus 2. So if we plug in negative 2, we can get rid of our a and our c to find b. So we plug in negative 2, and we get 9 over 5. And then to find our c, we have to plug in y equals 3, right? Because that'll get rid of our a and our b. And we get c is 1 over 5. So we take this equation right here, or expression, and we plug those values in for a, b, and c, and we split them up, and we just evaluate. Okay, so when we're taking the derivative, again, remember these scalar numbers just come out to the front, okay? So the 2, 9 over 5, and this 1/5 just come out to the front. And honestly, you should probably take the sign with it, okay? So we're taking all the positives. All right, so here, the derivative of y is 1, so it's just the natural log absolute value y. The derivative here, again, is 1, so it's just the natural log absolute value of the bottom. And again, natural log absolute of the bottom. And then we evaluate from 2 to 1. Remember, it's always top minus the bottom. Whenever you subtract, you should use parentheses and then distribute your negative, okay? The absolute values make things go to positive 1. Natural log of 1 is 0. You can either plug it into your calculator or go back to the graph of ln to see that. And then if they have the same ln, if ln is being applied to the same thing, you can combine them. So this 2 minus 5, 1 over 5, will combine into 9 over 5, right? 2 minus 1 over 5. To combine fractions, you have to have common denominators, so we multiply top and bottom by 5, which would be 10 over 5 minus 1 over 5, which would give us the 9 over 5, okay? And that would be our final answer.